Good afternoon, ladies and gentlemen. So our lesson today is going to focus on dividing mixed numbers. Now, we've been dividing fractions with whole numbers, fractions with fractions, fractions with mixed numbers. So this is really just more practice. None of the procedures are going to change. And we're using very similar models. Okay, and then I'm going to work with you a little bit on tackling word problems. So in this case, we have 2 2/5 divided by 4/5. So if our total is 2 2/5, okay, and then for whatever reason at all, we want to cut it into sections that are 4/5 each. Okay, so maybe we're cutting fabric or lumber. 1 4/5, 2 4/5, 3 4/5. Okay, now you can kind of see this and think about it really clearly when we look at this as 12/5 divided by 4/5. Now, I'm not calculating it. I'm just literally looking at the two numerators. They have the same denominator, so we're comparing fifths all the way across, and it would only work if you're working with the same unit. Well, I know that the relationship between 12 and 4 is that this is 3 times that. So it makes very good sense from a fraction standpoint of saying, oh yeah, well, 3 of those sizes will fit in this size. That's one of the really good uses of improper fraction. Sometimes it can help you to see the bigger picture. Okay? But for calculation purposes, this can be very, very efficient. They don't have to have the same anything. It'll work with any fractions all the time. And that's one of the reasons, well, it's the biggest reason, that I will consistently teach you to multiply by the reciprocal. Okay, the keep, switch, flip. Because it works with any fraction, anytime the numbers don't matter. Okay. But one of the things I did want to talk today about is word problems. Okay. If your parents are watching this with you, when we were kids, word problems bugged us too. It's not just a you guys thing. And a lot of it is just how to tackle it. So here's a story. Okay. 8 cups of dog food in the bag. Okay, so you have a bag of dog food. You've used up some of it, whatever. There's 8 cups of dog food left. Okay. Each day's serving for your dog or this person's imaginary dog is 2 2/3 cups. How many days oops, my brain and my pencil got ahead of one another, of food do you have? Now, we've talked about some things like this in class. The pancake problem, in real life, we don't always want to go to the store that very second. Sometimes we really are figuring out, all right, I can make it a few more days and then go to Costco or wherever we need to go. So let's think about this. We have a total, which is 8, divided by servings. Okay, servings are pieces or parts. And that size is 2 2/3. And that's going to figure out, okay, the number. And really, it's a number of parts, number of days, a number of pieces you could cut out, number of people you could serve, things like that. So 8 divided by 2 2/3. Well, that's the same as 8/1 divided by 8/3. 3 times 2 is 6, plus 2, that's 8. Okay. Making my document camera work a little extra hard today. So I'm going to keep, switch to multiply, flip the second guy, right? Because we're multiplying by the reciprocal. Oh, 8 goes into 8 one time, and 8 goes into 8 one time. I love that. So that equals 3/1, 3 days. You have 3 days worth of food left for this dog. So on day 2, please go buy more food because you don't want those sad puppy eyes looking at you and sad. Okay. Now I want to do 2 more examples with you. So I'm just going to turn this over to my work paper, just like we often do in class. Okay. On every lesson, you should have examples on both sides. And we're just going to kind of do a simple one. This one is a mixed number divided by a mixed number. 2.5 divided by 1 3/7. No, that does not look like something I want to do mental math with. So I don't have to. I can calculate it. This is our favorite improper fraction, 5/2, divided by 7 times 1 is 7, plus 3, 10/7. Now I'm going to multiply by the reciprocal. Keep, switch, flip. Always the second guy. Okay. 5 goes into 5 one time. 5 goes into 10 2 times. Oh, that made it even nicer. It wasn't too bad to begin with. So now I have 1 times 7 is 7. 2 times 2 is 4. Or, and probably a more useful number, 1 3/4. Okay, so if I took 2.5 feet of lumber and I actually needed shelves that were 1 3/7 feet, I could get 1 3/4 shelves out of that, but I'm not even going to get 2 whole shelves. Okay, that would be a practical application of these numbers. All right. The next one is going to involve something Mr. Atkinson loves and Mrs. Atkinson knows very little about. Okay, and it's called the sweet spot on a bat. So if you have a bat, and you will see a drawing of this in your textbook, and baseball players, please forgive me because this is just a sketch. Okay, there is a sweet spot to the bat. There is a spot that when you hit it, you know you did it correctly. Okay, in this particular one, the batter has figured out that the sweet spot on their bat is 6 3/5 inches in. So off the tip of the bat, 6 3/5 inches, that's the spot. Okay. And they know that their bat is 33 inches total. Okay. And what they're looking for is what fractional part of the bat is this here. Okay, and I'll explain to you at the end kind of why that might be important. But they're looking at what's this fraction here that I'm kind of shading in. Okay, so we want to take this piece right here, 6 3/5, and write it as a fraction with the total bat size. But that's the ugliest number you've ever seen. You don't want to do that. But remember, all a fraction ever has been is a division problem. So you can do 6 3/5 divided by 33. Oh, that's a much better way of doing it as far as how our brains process. Okay, so 5 times 6 is 30 plus 33. So this is saying 33/5 divided by 33 over 1. 33/5 times, keep, switch, flip. Oh, that was really generous of them. Maybe that's why they picked that bat size for this problem. Okay, 33 goes into 33 one time. 33 goes into 33 one time. They basically canceled each other out. 1/5. So according to this calculation, the sweet spot of the bat is 1/5 of the way in. In real life, this would be important because we bat with different sizes based on strength, based on height, based on preferences. So if this batter switched to a different bat length, if this ratio holds true, and my guess is that it does, about 1/5 of the way into your bat, coming off the tip right here, that's going to be your sweet spot. Okay, so a very practical application, and really looking at if I wanted to find a fraction of something, it's just a division problem. Okay, so I can't wait to see you back in class. We'll do some more practice. Have a great evening.